What's up, everybody? My name is Alex George. I have the childhood dream job of being an editor at Popular Mechanics magazine, and I'm here with Mr. Holmström here to talk about a invention that he's been working on. If we can get the visual up on stage of what of specifically what we're talking about. This is a screen capture of you decked out in a mine in northern Sweden, and the vehicle before you is the subject of our discussion. So for those who haven't seen the video or the images of it, what is before you in this picture?
Well, we have been working with autonomous vehicles and automation for many, many years. And we, as everyone else is doing in the industry, we are doing prototypes and we're doing tests with autonomous vehicles. And one way of doing that in, let's say, in the confined areas was that together with a very advanced mining company up in the northern part of Sweden, we went down in a mining pit 1,300 meters below the surface, and we were running then an autonomous mining truck. And you see me standing in front of it because it was a little bit a showcase then in front of my engineers at that time, then that if I dare to test the vehicle and standing in front of it so that it understands that someone is in front and stop at the right time, it was me to do it then from the very beginning. Then we still do tests and we are still doing development on the autonomous vehicles, and this is one way of doing it. It's in a confined area, it's very special, and it's in real operation, which is extremely important. It's easy to, or not easy, but it's easier to do a test when you're running around the corner, so to say, or running around the block. This is in real operation. It will operate in this mining operation then, running with the iron or with the ore from one place to another then, down in the pit then, 1,300 meters below the surface.
So off screen, it's an enormous, a diesel truck that you might recognize otherwise.
Yeah.
But tell me about, so what is the truck using to see that you're here and knowing to stop in time? What are all the geeky kind of LiDAR, everything that we were just talking about, all the redundancies that made you pretty confident it wasn't going to make you into a pancake?
Well, of course, we are using all the new technologies that comes up right now, as you heard just a couple of minutes ago then about LiDARs, radar system, ultrasonic sensors, cameras, of course. But what is important also is that we have for many, many years, all the way since the late 70s or the beginning of 80s then, stepwise then introduced systems and components in the vehicle that make the vehicle ready for automation. We have transmission automation, we have engine automation, braking automation, and lately we introduced then steering automation as a base for then taking the step and adding the new sensor technology and the computer technology and the software technology on top of that. And by that we are able now then to take the next step, because if you see then everyone else they are also talking about how do you make the vehicle itself then safe in, let's say, the autonomous era, which is very important. And we have been adding then features and testing that for many, many, many years, ever since the early 80s or late 70s.
So particularly to everybody who's had well-intentioned family members ask, what's going on with these self-driving cars? When are they coming? I'm partially responsible for those headlines, I apologize. But the specific thing that we talk a lot about is what advances have made inventions like this possible. And one of them is GPS and wireless communication. But a mine makes that very, very difficult. So it's different from any other environment. How do those essential parts work in an environment like that differently than above ground?
Of course, a GPS doesn't really function 1,300 meters below the surface, and high definition maps and so on. This vehicle, first of all, it makes its own map, which is one part of what self-driving or autonomous vehicle is doing. But on the other hand, this mining operation is very much in the forefront of technology. So it's there's a wireless system, Wi-Fi system in the whole mine, but there's also a traffic management system which controls or sees then all the vehicles, not just trucks, but other vehicles that you have in the mine, but also all human beings that are in the mine. And by that then ordering let's say, an autonomous truck to go from one place to another, but also then seeing that if something happens, something dangerous happens, then they have track of all the vehicles and all the human beings then down in the mine. So in this specific case, it's a combination then of a good and high technology in the mining operation, but also then what we can deliver then in this case.
And so this is something, so we talk about technology, where I work, we talk about technology, we also talk about home improvement, construction, these different things. This makes me think of ways that drones are being used to survey land or to do inspections and basically remove, take humans out of precarious situations. Now, talk to me about how, we're talking about mining, which is an extremely lethal profession. In a workplace, how does this change the workplace in terms of what are the very specific safety concerns that something like this addresses? And we were talking about ventilation before.
Yeah,
it's a place to start.
For sure. Underground mining, one of the most expensive thing that you're doing then in an underground mine is to ventilate. When you have a blast, you have a lot of toxic gases then down in the mine. You have to ventilate the complete mine, and it's not few cubic meters. It's an enormous amount of air that needs to go out and in of a mine and to get people down in the mine. If you could have, and when you could have autonomous vehicles, that doesn't really need that, let's say, clean air down in the mine. You could then send vehicles down in the mine without then ventilating the mine as much as you need to do then after every blast in the mine. So that is one thing. And of course, in mines there are accidents. You have rocks falling down and so on, which makes the mine much safer, and by that, of course, also much more profitable in a way. So you could use the mine for a longer time, and you don't need so much rich ore, so to say then. So you could run the mine with less content of the real, let's say, if it's gold or zinc or whatever that you're taking out of the mine. So
right. This is north of Sweden. It's a rare earth mine that you're in right there.
Yeah.
Talk to me about the experience of the people who are involved. I know there's a lot of the technology goes into being aware of the human beings that are nearby it. When something like this gets introduced to a mine, how does that change the workday for the humans involved?
Yeah, absolutely. If you take them typically for a individual that is running the vehicles, they can work for 4.5 hours, then they have to rest for at least 45 minutes, then can work for 4.5 hours again. And it's a very tough operation inside the mine. So there is a possibility then to run this type of operation then seamlessly. You don't have to rest. You could run the vehicles almost 24/7. You have to do some maintenance, and in the end, but a much more productive system, and you could use the infrastructure and the installed capital much to than in this case. And by that, of course, increase the profitability for the mining operation.
Got it. And it's communication from the surface down to the vehicle while it's in motion.
Yes.
What is the human involvement on that side of it?
There is a control. You could say it's a traffic controller and sitting on the surface, then overseeing then the whole operations from blast to transportation to the crusher and all the way up then to the surface, and from that all the way down to the next station, so to say. So.
And so it's outfitted with all this hardware that we just talked about too. But it's also is it a diesel truck more or less underneath it?
It's today it's almost a standard truck, then added the new sensor and the new software. So we today already have that truck in production. So it's very well tested, so to say, for many years.
And the thing that we were talking about before that is really interesting to me, if you've ever had seen somebody drive an 18-wheeler or a serious machine like that, and maybe this would be a number of years ago, but how many gears you have to shift and how much work has to go into it and how much your left leg works with the clutch and all that. The difference between then and now in terms of how optimized the transmission is and how optimized the steering is, all those different things. What's different? What else is different about that?
it's a very big difference. If you go back in history, once, I mean, a lorry driver or a truck driver, they were worn out and very, very quick by shifting and declutching and so on. So the elbows and the joints all over were worn out. And that started everything when it comes to automation. And we have to see to that the driver is less fatigue and will not be worn out and over time. And that started the whole era then when it comes to automation. In combination with new technology at that time, if there is someone here in this audience remember the Intel's 8085 microcontroller, that was the first one then combining, we had that microcontroller and on top of that we have the mechanical system then, and combining that into mechatronics, that took the first step then when it comes to automating transmissions, engines and onwards then all the way through then to where we are today. And today we are standing in front of a new step in technology where the new sensor technology, LiDARs, ultrasonic sensors, radars, cameras and so on, and software technology when it comes to sensor fusion, artificial intelligence and machine learning, that will make the same type of step and also the same type of, let's say, igniting the innovation spirit in the system going forward. Because all engineers, you that are sitting around here and everyone out there, they will understand that we can do that and that and that because we have that sensor system and we have the new software and the computing power. I mean, the graphic processing units that NVIDIA and others are now doing, they are the ones that will be what we need then going forward to do autonomous vehicles and to really come the next step in the coming years.
Talk about that, the adapting, the software side of it and the adaptability to it, because at least externally, it seems like that would be a semi-predictable, controlled environment compared to, say, somewhere with traffic or anything like that. But it requires a lot of energy to understand what's going on and actually become more efficient over time. What is it looking for, and what are the advances or the problems that you had to solve to focus on that and make sure it would really it would learn and adapt in ways that would be useful?
Yeah, I mean, of course, while we are starting in the confined areas, I mean, we have been running this in public systems like this in public area also. Then we had a platooning event then going from one place in Sweden to one place in Europe then over a lot of country borders and so on, where you have a platooning event with 3 vehicles, and we have also tested then platooning events between passenger cars and trucks, which is an amazing thing then to run 55 miles an hour with 3.5 meters, and you have one truck in front of you and one truck behind you and just let the steering wheel go. And it's possible to do that, but there's a lot of legislation that needs to be there, and there is a lot of test because all the operational modes you have to have, let's say, to be very sure about that if something happens, you fail safe or you fail operational, so to say. So that is what we are doing right now then to debug the system, as everyone else is doing then out there, but we are doing that also then in the commercial industry.
Right, and these are the redundancies that help ensure something like that, and, keep you safe like that. Yeah. The other thing I think that is uniquely interesting from your perspective is you started at Volvo in 1979, correct?
I did, yes.
Working on specifically it was automatic transmissions. Were I to show you something like this or a video like that to a young fledgling Torbjörn and explain what this is and what it does, would that make you say, yes, if I'm looking at what I'm doing right now, I can see that as an eventuality? Or are there parts to it that you're like, there are parts of this that were inconceivable back then that we can now wrap our heads around?
Going back then to 1979 when I started, we were a small, let's say, a startup within the bigger company. But of course, if you are, as I was at that time then, 24 years old, you think that everything is possible. So if someone would have told me then, please go out and do a autonomous vehicle, okay, let's start and try to see what we can do. But at that time, we didn't have the computing power, we didn't have the sensors, we didn't have the actuators. and so on and so on. And we didn't have the software technology that we needed. So we started what we thought was a big step at that time. And then we have added, let's say, continuously up until now. I think right now we are in front of a new, let's say, step change, because it was a step change when Intel came with 8085, the microcontroller that was done for, let's say, embedded systems, mechatronics, and real-time systems. I think we're standing in front of something new now, and I mean, the future will tell, but I would bet on that we will have, if you could call it then, the dronification of the society. We will have big drones like load-carrying systems that was in the past a truck, and we have smaller drones and so on, and going forward, the flying drones. That will be what we will see then going forward.
Yeah,
so.
I think that makes a lot of sense.
Yeah.
And I guess the thing that, at least editorially, requires a little bit of explanation too, is that it needs to be, I guess people want to understand it as being a giant, very drastic leap, but these iterations that are signs of progress, like outfitting an otherwise typical looking industrial truck with all this subdermal technology that's making it do a job that is not just augmenting what a human being would do, but actually affects how a given task is conceived of in certain ways. And I think that's, if I understand, that's a big part of your job too, is understanding what that will look like for somebody.
I mean, that has been my life for many, many years. But just so that you know, during my almost 40 years in the industry, it has always been the case that now this is something groundbreaking every time. But if I'm looking back and if I'm looking forward, of course there are some things that are step changes, but the real thing is then that as soon as you have something new when it comes to technology, the imagination starts then to work, and all of a sudden you have a lot of other things then coming up, and that's extremely interesting and rewarding then going forward. And I think this is also a part of then solving the issue with sustainable mobility going forward. We need mobility, absolutely. We need more mobility than to fight poverty and to distribute wealth in the world. But we need to have it sustainable, and that is the challenge for my industry and myself and my company going forward.
Excellent. All right, thank you. Thank you for your time. Thank you
very
all
much
for listening.
Yeah.
So on May 16th, they've got a big announcement. Please.
Thank you.
All right, thank you very much.